Shouldn't we want to start the lesson on electrolysis of copper 2 sulfate using carbon electrodes? The most important point to remember here is the reason why we use carbon electrodes, or the nature of the carbon electrodes. The nature of the carbon electrode is such that it doesn't react. Carbon electrode is unreactive electrode. Unreactive electrode. And here in the name, in the heading, we have electrolysis of copper 2 sulfate. When you write copper 2 sulfate, it means copper in this sulfate solution is in the form of copper 2 plus. Copper within bracket 2 means oxidation number of copper is +2. Now we see how this reaction works. As I always do, I can start the lesson with the diagram of the electrolysis cell. Let's say this is a beaker. And in the beaker, we can keep copper sulfate. Copper sulfate is blue. So I can add blue. Oh, not there. I think it's okay. Yeah, copper sulfate. This solution is blue because it contains copper 2 plus ions, basically Cu2 plus ions are blue. So this solution is blue. In addition, we have in this solution sulfate ions, SO2 minus, and hydrogen ions, and OH negative ions. And the question says that we are using carbon electrodes. If you use carbon electrodes, we can do carbon electrodes. Here, this is one electrode. This is another electrode. And this is not enough. We have to connect the cell DC source. Here's a DC source. We have the positive charge on the left-hand side, the negative terminal on the right-hand side. When you connect them to the electrodes also will be charged in the same manner. What I mean is, on the left-hand side, we have positively charged electrode. On the right-hand side, we have a negatively charged electrode. If I give the names, on the left-hand side, positively charged anode, positively charged anode, carbon anode, and over here, we have the cathode. That's the beginning of the lesson. Now the diagram is ready, everything's labeled, and the ions present in the solution mentioned. Next, we have to see what happens to these ions when the circuit is complete. Anode is having positive charge, so sulfate ions go towards the anode. Hydroxyl ions are negatively charged, they also go towards the anode. Okay. Then the next one, copper ions, positively charged. Hydrogen ions, positively charged. They both travel towards the negatively charged cathode. And then what happens? They begin to react at the anode and cathode. Anions are going to react at the anode, cations are going to react at the cathode. As usual, we'll start with the anode reaction. anode reaction first. There are a few things to remember. Do you know the type of reaction shown at the anode? Anode reaction. What type of reaction happens at the anode? We don't remember.
Oxidation reaction.
Oxidation reaction. Very well. Very nice. Oxidation reaction. At the anode reaction, when oxidation reaction occurs, actually oxidation means removal of electrons. Removal of electrons. We see what ion is going to react. When we have sulfate ions and hydroxyl ions, according to the knowledge we have, sulfate will not react. Hydroxyl ions will react. I gave you a rule, set of rules for aqueous electrolysis systems. See whether you can remember. If you have sulfate ions in a medium, sulfate ion, carbonate ion, nitrate ion, phosphate ion, likewise we can get many oxyanions. If hydroxyl ions are there along with them, none of this, sulfate, carbonate, nitrate, phosphate, nothing will react. It is always OH minus which is reacting. So that sort of a situation is here. We have sulfate ions and OH negative ions. What is going to react is OH minus. So I'll write here for the oxidation reaction. I remember this. When you do this several times, you also must automatically get this into your mind. 4 OH minus, otherwise they can balance this also. But since we do this very often, we remember this. 4 OH minus ions give 4 electrons. In the meantime, 2H2 plus oxygen. 2H2 plus oxygen. Now, because of this oxygen gas formation here, you will see at the anode tiny bubbles of oxygen coming out. Oxygen gas bubbles. That's the observation at the anode. O2 gas bubbles. Okay, that's it about anode reaction. We go to cathode reaction now. We get the heading first. Anode reaction can be changed to cathode reaction. Cathode reaction must be not oxidation, it must be reduction. Cathode reaction is reduction reaction. For the cathode reaction, we have 2 types of ions. First one is copper 2+, the other one is hydrogen ions. Before we start discussing the reaction happening at the cathode, there's one important point to remember. What is this? Read this carefully. When there are few cations competing for the cathode reaction, when there are few cations competing for the cathode reaction, the ion produced by the lower reactive element, ion produced by the lower reactive element Ion produced by the lower reactive element will participate at the cathode reaction. You can't forget this. When there are few cations competing for the anode cathode reaction, the ion produced by the lower reactive element will participate at the cathode reaction. According to this argument, if you see the periodic reactivity series from hydrogen and copper, which is at a lower level, copper is at a lower level. Copper is just below hydrogen in the reactivity series. I can say H2 copper. Do you remember this? Copper. After hydrogen, we get copper. So copper is lower reactive than hydrogen, and copper ions are there with hydrogen ions. So copper ions are going to react. Why copper ions are going to react? Because copper is lower reactive than hydrogen. Let me write here copper 2 plus. Reduction means taking electron. Because copper has two charge, positive charge, 2 electrons will come to the reaction and we get copper. That something is missing. I had to add physical state. Copper is aqueous. Copper 2 plus. So copper is solid. What's the meaning of it? From the solution, copper ions go to the cathode and deposit on it in the form of metal. The color of copper metal is reddish brown, or you can say pink. One can say reddish also. So I shift the anode reaction and cathode reaction a bit to the left-hand side so that I can have space to draw the diagram, the nature of the diagram after a while, maybe after 10 minutes. How do you think will this anode, the electrolysis system look like? I take the whole thing first. No, this is the also. Yeah, I'm going to modify this diagram to show the appearance of the electrolysis cell after a while. You should observe this clearly and tell me whether you get it clearly. I'll take orange, not orange, but red. Children, the cathode is going to change a little bit the way how I have shown here. Come on, what is this? On the left-hand side, cathode is fully black because it's carbon. On the right-hand side, we have the part of the cathode dipped in the solution red. Why? Look at the cathode reaction. In the cathode reaction, we have copper 2 plus ions getting 2 electrons and going to copper solid. Copper solid is actually the red copper metal. So this copper metal is going to deposit the electron below the level of the solution. Gas bubble formation at the anode happens as it is. You can't change it. But one more thing happens. The solution is blue because of copper ions. Copper 2 plus ions deposit on the cathode from time to time. As it happens, the concentration of copper 2 plus in the solution decreases. Therefore, solution is blue, its concentration decreases, therefore the color decreases. See, likewise, the entire solution goes to light blue. These are the biggest two changes. So if the question asks from you, what are the changes happening in the electrolyte? What are the differences in observation? Or you can simply say, what are the observations? We can say, at the anode, first observation, a gas bubble formation. And that's at the anode. And on the cathode, the observation is already substance deposits on the electrode below the solution level. And then the color of the solution goes from blue to light blue, or we can say color of the solution fades. This is everything about electrolysis of copper-2 sulphate using carbon electrodes. I hope you have understood. And probably we can go for some questions now. I have another diagram drawn here. Yeah, you can see this here. Electrolysis of copper-2 sulphate solution using carbon electrodes. See, it's almost the same thing. Only one difference is there. In my discussion earlier, we have anode and cathode switched. That's the only thing. Nothing else is different. Now this question is about copper sulphate electrolysis using carbon electrodes. Let's try to figure out the answers to this. Identify all the ions present in the electrolyte. Electrolyte means copper sulphate. What are the ions? Copper-2 plus.
SO4 2 minus.
SO4 2 minus, wonderful.
OH minus.
OH minus, excellent.
H plus.
H plus ions. Thanks a lot. What ions travel towards the anode?
SO4 minus and OH minus.
SO4 minus, 2 of SO4 2 minus and OH minus. So to the cathode, H plus and C2 plus. Give me a second, I will change the thickness of the pen. And get a different color, probably it's more suitable. Yeah, what ions get liberated at the anode?
OH minus.
OH minus. And for the cathode?
Copper 2 plus.
Cu2 plus. Write the balance equation for the reaction that occurs at anode.
For OH minus. Gives 2 H2O plus 2 oxygen plus 4 electrons.
Wonderful. Cathode?
Copper 2 plus 2 electrons give copper solid.
Okay, anode reaction is given, cathode reaction is given, no problem at all. It's the perfect two reactions happening at the anode and cathode. Thanks a lot. Now we have to construct the overall reaction for this electrolysis in the next step. In other words, we have to see what is happening overall in the reaction. How can we do it? Or add the anode reaction and cathode reactions together, but how can I do it?
There should be equal electron amounts.
There should be equal electrons in the system. But the problem is at anode, we have 4 electrons and at cathode, we have 2 electrons. What can I do now?
Multiply the whole second equation by 2.
Excellent. 1 is going to be added to number 2, which is multiplied by 2. I will do it straight away and write over here without constructing a third equation of the second equation. Due to multiplication, it changes. I'll consider this change straight away during this addition here. This should be plus 1 plus 2 into 2. From the first equation, we have 4OH minus. That's the only reactant from the reaction 1. Now reaction 2, we have copper 2 plus. When you multiply by 2, you go to 2 copper 2 plus, 2 copper 2 plus there are 2 electrons, it must be 4 electrons. Those are the only reactants in reaction A and 1 and 2. Now I go to the product side. From the reaction 1, we get 2H2O plus oxygen plus 4 electrons. And from the equation 2, we get only one product, which is copper, but has to be multiplied by 2, so 2 copper. You can see 4 electrons on the left-hand side, 4 electrons on the right-hand side, they cancel out. Remaining ions are 4OH minus plus 2Cu, 2 plus on the left-hand side. And they produce 2H2O plus O2 plus 2Cu. Yeah, this is the balance equation for the electrolysis. Next part, anode cathode. What observations, write the observations that you can make at anode. What is the first one? Anode, gas bubbles. Cathode, red substance deposits on the cathode. Red substance deposits on the cathode. We can see red substance deposits on the part dipped, on the part dipped. Wait a minute. No, I have to change this. On the part red substance deposits on the part of the cathode. The red substance deposits on the part of the cathode. Dipped in the electrolyte. How do you expect the electrolyte to change as the electrolysis proceeds? Solution has copper 2 plus ions, sulfate ions, hydrogen ions, hydroxyl ions. For the cathode reaction, copper ions go. For the anode reaction, hydroxyl ions go. But what are remaining? Sulfate ions and hydrogen ions are going to remain. So acidity of the solution increases and the solution slowly changes to dilute sulfuric acid. We can write as copper 2 and hydrogen ions. It's copper 2 and not hydrogen.
It should be hydroxide.
Hydroxyl ions. As copper 2 and hydroxyl ions react, the concentration of hydrogen ions, increases in the solution. Hence the solution becomes acidic. Okay, this is the end of the electrolysis of copper to sulfate solution using carbonate. I guess you understood everything.